This section is just an extension of our sampling terminology and some other key concepts. A statistic is used to describe any kind of numerical information drawn from a sample. So, say for example, at school you want to know the average GPA within the entire school. Well, in order to do that, if you didn't want to sample every single student in the school, you would take just a sample of some students, and you take that statistic, and hopefully that sample is as least biased as possible. You take that average that you get, and you try to make an inference about the entire school. So, statistic is we're gonna say this comes from the sample. Okay, so that comes from the sample. And don't get this confused with the parameter. So parameter is an estimate for some unknown measure of the population. So say something, say it's something that's really hard to get exact for the entire population. That's why we take a sample in the first place. So our parameter is, for example, the exact average GPA of the entire school. But let's say for some reason we just can't get that information, so we take a sample. But that parameter that we would like to know, that is referring to the population. And it doesn't mean we can't actually find it. If we were to give out a census, we could actually get the exact number, and that would be our parameter. Sampling error, so that's used to describe the difference between a parameter and a statistic. So how far off were we from the number we got in our sample versus the actual mostly correct number we would have gotten from doing a census for like the entire population. These definitions are pretty straightforward. Chance error, so this is just the result of the basic fact that a sample, being a sample, just the sample itself, can only give us approximate information. It's never going to be exactly what the answer would be from an entire population. So if I were to take a sample and take the GPA from only a certain number of students, it'll never be the exact average GPA of the entire school. It could be close, but it won't be exact. And sampling variability, different samples are likely to produce different statistics for the same population. So if I take 50 students and get a certain average GPA, and then I do the same thing, I sample in the exact same method, but 50 different other students, chances are that those statistics are going to be different. They may be close, but usually they'll be different. Okay, here's our last two vocab words. Sample bias, the first one here. This is just the result of choosing a bad sample. This really is a much more serious problem than just chance error. Chance error is just a natural thing. It's not, any sample is not going to give us the exact amount that we would expect for the parameter. But you really do need to be careful when you're taking any kind of survey or doing any kind of study that you avoid any bias with the sampling technique that you choose. And sample proportion, so that's just going to be a number we get out from taking the size of the sample, denoted by lowercase n, to contrast with uppercase n, the size of the population. So, for example, if I had a school that had 2,000 students, and I were to sample 50 students, well, my sample proportion would just be 50 out of 200. So again, this is just the ratio of people sampled to the total number of people in a population.